walk you through our first big group project. We just started this yesterday for the year. And what it is they're building these trebuchets. And they're going to start off, we're going to have a class competition. That's the ultimate payoff, where they have to shoot a ball at a basketball hoop, and they'll have points for different ways that they get it. So we start off with prototypes. So they're going to build a cardboard prototype to get the idea of the physics of how a trebuchet works, and kind of what they need to pay attention to in terms of release mechanism, and just making sure that they can kind of see how the trebuchet functions. It's also, I put them in groups, so I get a chance to see how these groups are going to function. This project will take us probably about a month, and so I want to make sure that I have functional groups. And so this is a good first test because it's pretty low stakes. It's just out of cardboard, but it allows them to really have to work together. And so the way that we do this, so you can see that we have our cardboard. We talk about what makes things strong. And so taking a piece of cardboard on its own isn't very strong structurally, but if we laminate them together, we can get a much stronger material. And so you can see down here at the bottom, yesterday just glued up a bunch of panels. So they took a bunch of cardboard and we used wheat paste glue to put it together. And what they'll do when they come back is they'll actually take that kind of rough cut and they'll trim it up on the bandsaw to get their actual pieces so that they create it. And you can see we have kind of these half lap joints here in our cardboard, and that's going to be one of the new things this year that we focus on in terms of our construction. They also have to create this beam, and so the beam is out of popsicle sticks. Again, same idea of how do we take something that is relatively weak on its own and by basically lamination create something that's much stronger. So they'll take about a week to build these, test them, they'll use a ping pong ball for it, and then their next step is to build the real one. And so they get some design leeway on this. They get to kind of come up with a design that works for them. For our weights here, this is just a work in progress. We'll use concrete to build some concrete blocks that will be our counterweight as this thing swings down, and have our release mechanism. You can see again, I'm going to require a couple of half lap joints for their project to be complete. This is new this year. Last year we basically just screwed everything together, and I really wanted to focus a little bit more on like complex joinery in a low-key setting. It's not fine furniture, but it gets them at the idea of how you would put something together in a way that maybe is a little bit more, put something together in a way that it's a little bit more complex. It also gives it a lot of rigidity and strength just built in by that piece. And so when I came up with that idea, it was like, I have an idea, and how do I make it so that kids can do it and do it safely? And that's often where things become a little bit tricky for me in terms of teaching a class versus doing something on my own. So if I was doing it on my own, I'd probably use a dado stack to carve out that material. However, I don't want to do that with students. And so we went through some different ways that we could actually do this. We have the miter saw, and we have our depth stop. So I tried doing it with the depth stop, but I didn't like how that was in terms of I only have one miter saw with the depth stop, and that's going to be hard for students to use. I then built this jig for our routers. We have a couple of routers. I didn't really like this either in terms of how students would be able to use this to carve out those half lap joints. It seemed a little bit sketchy. It also seemed like it wasn't as accurate as I wanted to be. And so we came up with was this sled here, or this jig, sorry, for the circular saws. So this is going to allow them to create basically a bunch of curve cuts at the 45-degree angles that they might need, and then as well as a 90-degree angle. So this is what we're going to land on. They'll do a bunch of curve cuts, and then they will hog out that material, use a chisel to make it a fine or fit, and then go from there. So why do I like the group projects? First and foremost, they're fun for kids. It puts another dynamic into the class where they can work together, but also like build something big. So I have about 60 students. I couldn't have 60 trebuchets but I could have 12, right? And so this allows us to have something that is much larger, takes up more space, but doesn't fill the whole shop up. And again, is a really nice way that we can have some different feel to the year. The other thing that I like about these is we double dip on these materials. And so cost is always important when thinking about a project. Roughly, I can spend a little over $2 a kid per week, and I'll be okay in my budget. So I can give, they are limited to 4 2x4s for this project. And so I can give them a 2x4 per kid, and it lasts 3 to 4 weeks. And then what we do is we use this material for projects down the road. So this is a table that a student made last year that is from the trebuchets. So we do a lot of rip cutting and then resawing of our 2x4 material to be able to create projects down the road. So that $2.50 of a 2x4 can get us in our shop, weeks and weeks and weeks of student work, which is a great thing to do. So as the projects come together, I'll try to get some video of creating the concrete forms and then the actual competition. But I think it'll be a lot of fun for students. They really enjoyed it last year. And like I said, just a kind of different flavor to what we usually do in the shop.